Today, I'm going to stay in Russia because I love Russia. I hope all of you are ready to see something very, very, very special. When it comes to new brittle materials, these guys, Polarus, have secret recipe. Thank you very much, Katherina, for being with us today. Tell us how you're going to revolutionize the laser-based material processing, especially for ceramics, and I'm especially interested in ceramics for consumers, displays. Let's see how you can do. Polarus, I really, really like this technology. The floor is yours.
Thank you so much, Jose. Hello, ladies and gentlemen. My name is Katherina Khodunova, and I am from Russia, from Troitsk, and I'm the executive director of POLARUS. This is the first time when POLARUS are joint meeting of the online EPICS meetings. And on my report, I want to introduce startup POLARUS, our laser, and how lasers scale up business in global cooperation. We founded in 14 by TechnoSpark Special Building Company. And our main task was R&D and manufacturing of picosecond lasers. We based in Troitsk. Troitsk is a small town near New Moscow, in New Moscow now. And in Troitsk, we have a nice community of photonic companies and research institute from Russian Academy of Science. We are not a big company, we are small. We have just 10 employees with optical, mathematical, software engineering background, electricals, and the different. And our main business segment, we developed laser for micromachining. And since this year, we are the member of EPIC. And throughout of the whole life of our company, we try to develop a high quality laser, but also to integrate POLARUS to the global companies and global cooperation. So what about our product? Well, our main product, we create a laser for industry. Our main product is laser PL Alpha. During 5 years, our main task was finalized R&D. And when we started to develop a laser, we have 2 difficult tasks. First, reduce the cost of some laser elements and use a short fiber in laser design. So what kind of laser we have? PL Alpha is based in mobile configuration with full fiber scheme. The core part of the device is in amplifier based on high-doped fiber. Pulse duration is 50 PC, average power 10 watt, pulse energy 7 G. PL Alpha can be integrated within a laser system via RS232 or DB25 interfaces. The input laser parameters adjusted via G. Laser is a code and designed for zero maintenance for 24 and 7 operation in industrial environment. So about our technology. We use a high allowed active fiber technology. This fiber is used in the main laser amplifier as a medium for amplifying ultrashort pulses. As a seed laser, we used a semiconductor pigtailed laser with an electrical driver which allows generation ultrashort pulses. What kind of technology advantages we have? The first, highly doped activity fiber can reduce the light of the amplifier by an order of magnitude. And even taking into account the higher cost of metal of such fiber, the cost of the final product is significantly lower than the cost of using the standard low allow fibers. So it is very important for us. Also for this fiber, it is necessary to use the lateral pumping method, which is eliminated by the optics, multiplexers, or combinates, which are also reduce the cost of the final product. Potentially, this fiber is also is intended to be used in preamplifiers. This will make it possible to exclude multiplexer from the optical circuit of the device, as well as to replace butterfly diodes as a pumping preamps with a cheaper multinode diodes. And the second, the approach allows us to use expensive master lasers based on the more synchronization, but to replace them with a relative inexpensive butterfly semiconductors, laser, and also relative inexpensive electric drive in our own design. In addition, our drivers have the potential to further reduce the pulse duration, which will compete with even more expensive competitive technology. So exciting. We have a technology has significant potential to reduce the pulse to 20 PC and increase the laser power to 30 watt without a significant change in laser design. So our technology had a great potential for the future. And we create a laser for industry. And our laser already being used for steel dicing, scribing, micromachining, some face making, And the main materials, metals, semiconductors, isolator, ceramics, sunglasses, and the other materials. Even at the R&D stage, we realized that it was impossible to create a laser company if we were focusing only on Russia contractors and not building up cooperation with worldwide market leaders. Of course, of most our components we buy not in Russia, buy in UK, England, France, and the different companies in the world. But the matter is not only in suppliers. We didn't limit to test our laser in our laboratory and involved this task in Russian company, and now to plan to give our laser to testing to the big laser institute in Germany. We understood that we're developing for standard mass application and the production of such lasers should be close to the manufacturers of laser systems and close to the main consumers in order to quickly manage to respond to consumer demand. Therefore, we began to think about the production of our laser not only in Russia, but in the world in Europe. Now we are planning to organize 2 production points, one in small in Russia with our partner Laser Spark, and second in China with our partners from BDL, with him we discussion about our preparation of manufacturing. And our founder, TechnoSpark, opened a representative office in Technopark Spark in China. And we work with them with future customers from China and attraction of investment. So about R&D task I said in the previous slide. So what about production? Laser manufacturing for us is a separate type of business, and it couldn't be quickly establish organizing an R&D company in Russia. And we went 2 ways. We decided to organize 2 production facilities, how I say, one in Russia with the help of small contract manufacturer, Laser in Troitsk, Laser Spark. And now we assembled the first batch of our final version of the Pale Alpha in Laser Spark and plan to give this product to the test. In the parallel, we are discussion with the DL ETG about organization manufacturing Pale Alpha in China. VDL is a large contract manufacturer worldwide with headquarters in the Netherlands and factories in Europe, Singapore, China, and we have a plan to organize production in China in 2021. How we are working on our benchmarking testing and what kind of results we have. When we create our first prototype, we give our laser to the one of the laser company in China to make a benchmarking testing by stealth dicing process on sapphire substrate. We have a good result, how you see, no low rawness and no defect in the picture. And also we test trials to our laser with our TEF positioning system in Laser Spark, and we do scrape of a thin metal film on a quartz surface. Metal film thickness is about 50 microns. And now we are working on a building database of laser materials interaction of industrial process, scribing and stealth dicing with, and we have a plan to cooperation with Fraunhofer University and with laboratory of ultra-short pulse processing laboratory. So at the last, why we're here, POLARUS is a young company, and for us it is a good place to be in contact with the future partners. And we're ready to consider new offers from suppliers for higher terbium doped fiber, acoustic optical modulators, seed lasers. And of course, we're looking at partners to test our laser in industrial laser system. Thank you for your attention. I am and my colleagues will be happy to answer for your questions. Sorry that I was so